Now see here diamagnetic substances. So how do these diamagnetic substances behave when they are placed in magnetic field? Whether the magnetic field is uniform and non-uniform magnetic field. And what are the values of the I, that means intensity of magnetization and magnetizing force, and also relative permeability of the diamagnetic materials. On the basis of all these parameters, we will categorize the materials here. And first I have taken the example of here the diamagnetic substances. Now see here there is a magnet, two poles of the magnet north and south, and now magnetic field is going this side, that is this magnetic field is taken as H or B naught, that is called magnetizing force or magnetizing intensity. Now when a diamagnetic material is placed over here, it magnetizes in the opposite direction of the applied magnetic field. So the intensity of magnetization is opposite to the applied magnetic field. But see here, the value of I is here not very high, that has a small value, but it is a negative value because magnetization is taking place opposite to this. So we can show also the graph for this. We can take like this graph here. If you have taken here I and here is H, the graph is something like that. So for the diamagnetic materials here I varies with the H linearly, but it is here the negative value of the I here. Now if I is negative and has got a small value, we know here chi m is equal to I upon H. So if I is negative, so obviously the chi m is negative and has got a small value. So if the chi m is negative and a small value, then mu r is less than 1, because we can write here the mu r is equal to 1 plus chi m. So mu r is less than 1. If mu r is less than 1, since we know it here, the mu r is equal to here mu naught upon mu naught, that is a permeability of the material in the free space. So here obviously mu is less than mu naught. Now another property, when the diamagnetic materials are placed in non-uniform magnetic field, they move from stronger field to weaker field. So when you place these diamagnetic materials in this non-uniform magnetic field, the movement of the is given like this, that is from stronger to weaker magnetic field. Now another point is also here related to this diamagnetic material. Here the diamagnetism or the diamagnetic property arises due to orbital motion of the electrons. So see here, in the diamagnetic materials they are found in the they are having the paired spin. So net magnetic dipole moment is 0, but when you apply external magnetic field, there is change in the orbital motion of the electron, but it is in opposite direction to the applied magnetic field. That is why the net magnetic dipole moment gets induced in opposite to the applied magnetic field. So now see another property or the another property of this diamagnetic substances here. You know about the superconductors. When the superconductors are placed in magnetic field, so suppose you have taken any superconductor over here and magnetic field lines are expelled by this superconductor. It means magnetic field lines are going like this. No magnetic field lines prefer to pass through the superconductor. In this case, inside it you can say the B is equal to 0. What happened? Here if this is here I have taken H, so induced magnetic field inside it, that will be equal to here the minus I, that is intensity of magnetization, that is equal to H. Then only the net magnetic field inside the this one can be 0. So inside the superconductor B is 0 here, it means superconductor shows perfect diamagnetic property or the perfect diamagnetism. And this phenomenon is also known as here Meissner effect. So value of the chi m for the superconductor, that is chi m is equal to minus 1, because I is equal to H but is in opposite directions. So we can write chi m is equal to minus 1. Obviously if chi m is equal to minus 1, then the mu r should be equal to 0. So this is about the superconductor. And now see also one important property here, the diamagnetic property of the material does not depend on the temperature, it is independent of the temperature.